Hello, and welcome back to Vector's All Things PC-lint Plus YouTube series. Once again, my name is Jacob Colapietro, and I'm a field application engineer here at Vector. This is part 2 of the series, where we will be covering how to get your project's compiler options into your PC-lint Plus setup. In the last video, we discussed the process for creating a compiler configuration file for your setup, so go check out that video if you'd like to know more about that topic. And let's get started. All right, so to start off this video, I just wanted to reiterate a couple things that I mentioned in the previous part. I first wanted to again mention that there's 2 main requirements for PC-lint to run in its most basic capacity. The first is the compiler configuration, which we set up in the previous video. The next is the name or a list of source files. However, when I say the name or a list of source files, that's a bit broad. We saw at the end of the last video that with just the compiler configuration and the name of a source file that we didn't get any meaningful output from PC-lint Plus. This is because we were missing the actual compiler options from our project. Things like our include paths or our defines. So in today's video, we're going to discuss how you can automatically generate an indirect file that contains all of your project settings in order to get meaningful output from PC-lint Plus. So in order to do this, there's 2 main options. The first is if you're using CMake or any other build system that can generate a compilation database, also known as a compile commands JSON, then you can use that to get all your options and sources you need. If you don't have that file, then you can use the PC-lint provided Imposter.c program. This program basically acts as a build system wrapper in order to pull the commands during a build. So we'll be going over both those methods today. All right, so again, I've moved over to VS Code where you can see the script we worked on last time. So we ended last video by using the compiler configuration to run PC-lint Plus on the source file from our code base. So we have that output in the terminal below here. And as you can see, PC-lint is having trouble locating this export.hpp file that's coming from our source file. So what's the actual problem here? Well, as I mentioned, PC-lint has no visibility to that header file. So in this case, PC-lint kind of works like any compiler that you may be using. And in saying that, I want to specify that PC-lint's not a compiler, it just behaves similarly to one in this instance. And what I mean by that is you need to provide it with everything in order for it to have visibility on all of your code. So that means paths for any headers that's included, or define any macros if you want, a section of code to be seen that's using a macro to guard it. And I'd also like to point out before we move further that this type of error will generally come from include files within your code base and generally not the standard libraries. And this is because we generated the compiler configuration already, so most of the standard library paths that we would need are already in this setup, as you can see here in the code-gcc.lnt. We have those all right here. So PC-lint Plus currently has no information regarding anything like defines or any includes for the source file outside of the standard libraries. So nothing about any of the headers from my code base. This is because we didn't provide any of that on the command line with the source file. We just kind of tacked the source file on the end of the command. So that brings up the question, how do we fetch these options quickly and easily? So I mentioned there's 2 main options in order to generate your project configuration. The first option we're going to go over is to utilize a compile commands JSON file. If you have access to that, this is the option that you should be using. So if you're using CMake or another build system that can generate this file, go ahead and have it generate that JSON file. And this file will just contain every compile command for the source files or the modules within your code base. So to use it, we're going to be employing that pclp_config.py file as we did in the previous video, except this time we're going to format the command to use the JSON file to generate a project configuration instead of the compiler configuration. So all we'll have to really do is tweak the command that we wrote from last time. So I've already copied the call to the Python script here on line 9. So what options are we going to need? Well, we'll still need the -- compiler equals GCC option. And as I mentioned previously, I'm using a GCC compiler, but this option is where you'll input whatever compiler family you're using. So if you're using IAR or Kyle or Clang, for example, you'll just put that in here. And if you want to see the list of options for every compiler that's supported for PC-lint, just do the -- list - compilers option with this script, and it'll output the list of all supported compilers. So the next option we're going to need is -- compilation -db equals. And this is just going to tell the Python script where our compile commands.json file is located. So mine's going to be located in this source base directory that I set here on line 3. And you can see that here, it's in this build directory within my code base. And if I open that up, you can see some of the compile commands that we have here. So I'm just going to point it to that, source base dir /build /compile _commands.json. So the next option we need is -- config -output -lnt -file equals. So we used this in the previous video to tell the Python script where to put our compiler configuration. It's the same thing here. We're just telling the script where to put our project configuration. So I'm just going to give it a name here. I'm going to give it project.lnt. And you can give it any name. You can give it something more meaningful than project.lnt, but I'm just doing that for the purpose of this video. So the next and final option we'll need is -- generate -project -config. And this is just telling the script that we're generating a project configuration. Last video we used -- generate compiler configuration, but we're not doing that this video. So we're telling it to generate a project configuration instead. So now that that's all set, we can go ahead and save this script and run it again. All right, so now that that's run, you'll see we have this new project.lnt file that was just generated. And if I open that up, you'll see we have a lot of output here. So the first thing that we have is some -ds. These are just defines that were found within the compile commands.json. Next, we have some -is, and these are just some include paths that were found within the compile commands.json. We also have this -standard. I also want to point out the names of all our source files are included here. So if I scroll down, you'll see there's a lot more .cpp files that we have. And that's great. So we have a list of source files. We have all of our compiler options all in this one file. So now, if we actually want to run PC-lint using that file, last video, we called PC-lint this way. We did PC-lint, passed it our compiler configuration, and then just gave it the name of a source file. Well, this time, we're going to call PC-lint, give it our project configuration, or our compiler configuration, and then our project configuration. So I'm going to uncomment that and save this. So this is just going to tell PC-lint to run on all of our project files. So I'm going to run the script again. And this time you're going to see that PC-lint's going to have significantly more output. And obviously this build is going to take a little bit longer because we have a lot more source files listed instead of just the one. But you'll already see that we're not running into that missing include file right away. So that's great. We're getting past those missing include errors. We have all our compiler options already set up here. So I'm just going to let this run. It's going to take a little bit longer, and I'll be back once it's finished. All right, so that analysis utilizing the project.lnt file that we generated using the compile commands.json is finished up. So if I start scrolling through this terminal output here in the bottom, you'll see that we have significantly more output than we were getting before. And that's because we have all of our source files listed out in the project.lnt file. So a lot more C++ files are listed, so we were doing analysis on a lot more files. But the other reason is because we had all of our compile options in there. So we had all of our include paths, we had all of our defines, so we're not running into any errors where we're missing includes or we're missing out on code because we don't have some things defined. So we have a lot more meaningful output here from PC-lint Plus. So using that compile commands JSON is a great option if you have that available to you. But what do you do in the situation where you don't have that available to you? So as I previously mentioned, there are two methods that we can use to generate the project configuration. So the first that we just went over was utilizing a CMake build system to generate a compile commands JSON and generate the project configuration using that. The other that we're going to now cover is to use PC-lint's Imposter tool. So Imposter comes in the form of a C file that's located in the config directory of our PC-lint install, as we can see right here. So great, how do we use Imposter? Well, Imposter's made to be used as a stand-in for your compiler within your build system. And it'll log the compile options from your build system as they're called. And it'll output to a file that can then be used by the pclp_config.py script once again. So to demonstrate how you use Imposter, I'm going to be using this tutorial code from VectorCast. It's one of our other products used for testing code. So this code base just uses a simple make file that I created in order to build. However, the method that I'm going to be employing to utilize Imposter can be mimicked with any other build system you may be using. I'm just using make in this case. So there are a few things that we need to set up in order to use Imposter. The first is to set an environment variable to tell Imposter where to log the build arguments to. So this variable is called imposter_log. And you can see on line 8 here, I have set imposter.log or imposter_log to output the commands it finds to this imposter.commands file, and that'll just show up here in this lint directory where our script is also located. So once we have that done, the next thing that we need to do is compile that imposter.c file into an imposter.exe. And this could be done with any C compiler. You can see I've already done this before, so I have this imposter.exe. You could do this with any C compiler. We just need to compile imposter.c to imposter.exe. And you can see I'm doing that here on line 17. Once again, I just have gcc imposter.c and then outputting to an imposter.exe. So it doesn't have to be done in your script every time. You can just do it once and then never do it again. It just needs to be done. So after compiling Imposter, we get into actually using it. So the bread and butter, if you will. So what do we need to do? Well, you will need to modify your build system slightly just by telling it to execute the imposter.exe that we just compiled instead of the compiler for your project. So every build system has a way to do this. As I mentioned previously, I'm going to be demonstrating this with make. So instead of my compiler, make will then just call the imposter.exe instead. So how can we do this with make? Well, we can do this by modifying one of two environment variables depending on what our project uses. See, make designates two environment variables to tell itself where the compiler it's using is located. So for a C compiler, it uses the variable cc, and for a C++ compiler, it uses cxx. So all we need to do is modify one of those variables to point to the imposter.exe that we just compiled. So moving on in the script, on line 18, I am pushing to the directory where my make file is located. And then on line 19, I'm running a make clean. And then on line 20, I'm actually running our make build. So you can see on line 20, I'm actually running make to build my target. And what you'll notice is I'm running make-e cxx equals and pointing it to our imposter.exe file that we just compiled. The -e cxx equals just allows us to modify the environment variable and point it to our imposter.exe as we call make. So this is just going to call our make build with the imposter.exe as the compiler to build our manager app target. So if this is all set up correctly, what we should expect to get is a file called imposter.commands to show up here on the left. So all I'm going to do here now is just run the script again. Alrighty, so as you can see on the left here, that generated a imposter.commands file. And if we enter this file, what we'll see is, as before, it kind of looks similar to this compile commands JSON, just formatted a little bit differently. But you can see we have a -i system with a directory, some -i's, a -o, a -g, a -standard, and some -w's, and probably some other stuff afterwards. So this is basically just a similar compilation database to the compile commands JSON, just containing all the commands that Imposter found from our make file and just put them here. All right, we have the imposter.commands file. So how do we use that to generate the project configuration? Well, I mentioned previously, we just used the PCLP_config.py script again, just modified slightly from our compile commands.json build. So you'll see on line 24, I'm using that script once again. Python PCLP_config.py, once again using the -- compiler option. Once again, using the --config-output-lnt file option and the --generate project config options. The only difference is this time we're using an option called --imposter-file instead of the --compilation-db option. And in that option, we're just passing it the imposter.commands file that we just created. So just going to run the script again, and if everything's set up correctly, we'll expect to see a new file up here called project_imposter.lnt that contains all the commands from our makefile build. Awesome. So we have a project_imposter.lnt. And you'll see it looks pretty similar to our project.lnt that we generated earlier. It just contains, the -i's, the -standard, all those options that we saw in the imposter.commands file. So once again, if we want to run the analysis, we'll just call PC-lint, use our compiler configuration, and then this time we'll pass it the project_imposter.lnt. So I'll go ahead and run the script again. This one's going to be a lot faster because there's a lot less files in it. So I might be able to stick with you here while it runs. Yeah, there we go. So it's run all that PC-lint analysis, and you see there's a lot more analysis than we would expect to get if we were missing those includes. So great, we have another method by which we can generate that project configuration and get more meaningful output from PC-lint Plus. So to recap today, we went over 2 methods by which you can generate a project configuration for your PC-lint setup. So what is the project configuration? Well, the project configuration is a file that will contain all of the compiler options for each of the source files, as well as the names of those source files for your PC-lint project. And with this file, you can run a more complete and meaningful analysis on your project and won't get stuck on any of those missing include errors that we were getting last time. So the 2 methods we went over, the first was using a CMake build system with a compile commands JSON. The next was using PC-lint's own Imposter tool as a build system wrapper to pull the commands that way. And then both of these, you just use the PCLP_config.py script once again to generate the project configuration. So please remember to tune into the next video where we will be covering more useful options that you can use with PC-lint Plus. So things like message suppressions, how to enable different coding standards, and changing your PC-lint output. And then remember to check out last video if you want to learn more about the compiler configuration. Thanks again for watching, and I'll see you next time.